In this video, we're going to graph or sketch polynomial functions. So first we have f of x equals negative x cubed plus x squared plus 3x minus 3. So if you want to graph this, first let's check the end behavior. Our degree is 3 and leading coefficient is negative 1. So our end behavior is odd. Since degree is odd and leading coefficient is negative, you know that our end behavior will look like this. As x goes to negative infinity, f of x will go to infinity. As x goes to positive infinity, f of x will go to negative infinity. Now we need to find what's going to happen in between. So what we're going to do is we're going to choose 5 points near x equals 0. So we're going to choose x, and we need to find f of x, which is our y value, around x equals 0. So we're going to choose negative 2, negative 1, 0, 1, and 2. And we need to find the y values for each x value. So we need to find f of negative 2. And you already know how to do that. All you got to do is plug in negative 2 for x, and you end up getting 3. You might want to double check. Pause the video and double check that f of negative 2 is 3. What about f of negative 1? Again, you might want to pause the video and check that f of negative 1 is negative 4, and so forth. F of 0, f of 1, f of 2. And when you evaluate it, you will get negative 3, 0, and negative 1. So here's our y values. So this means the polynomial will go through negative 2, 3, negative 1, negative 4, 0, negative 3, and so forth. So based on the given information, I plotted these 5 points on the graph, and knowing how our end behavior will look like, it's going to look like this. Okay, something like this. Notice our end behavior, it goes up and this goes down. And you might want to double check with your graphing calculator or Desmos, but this is how you would sketch this function. Now we have f of x equals x to the 4th minus x cubed minus 4x squared plus 4. So how can we graph this polynomial? First, let's look at the end behavior. Degree is 4, which is even, and the leading coefficient is positive 1. Therefore, you know that our end behavior will look something like that. It's going to go to positive infinity as x goes to negative infinity. And as x goes to positive infinity, f of x will go to positive infinity as well. Now, we need to find out what happens in the middle. So again, we're going to choose 5 points near x equals 0. So we need to find x equals negative 2, negative 1, 0, 1, and 2. So what is f of negative 2? Again, you want to pause the video and evaluate when x equals negative 2, and you end up getting positive 12. What about at f of negative 1? You'll get positive 2. And f of 0, that's very easy. All you got to plug in 0, and you end up getting 4. And f of 1, you end up getting 0. And then f of 2, you end up getting negative 4. Now we need to plot the points and sketch the graph. So using our end behavior and 5 points on the polynomial, which we got from this table, we know that the polynomial will look something like this. Okay, it's not the best graph. I'm using digital pen. You could do a better job than I do on your paper. So this is how the polynomial would look like. And again, you might want to use a graphing calculator or Desmos to see if our sketch is similar to our actual polynomial. Now, before I talk about next example, we need to talk about when function f of x is increasing and decreasing, and when f of x is positive and when f of x is negative. So let's look at this f of x. Whenever you talk about whether a function is increasing or decreasing, you have to look at it from left to right. Okay, remember, left to right. So looking at it from left to right, when is function f of x increasing? It's increasing whenever x is less than -2. Look, it's increasing until x equals -2. So f is increasing when x is less than -2. Also, it's increasing whenever x is greater than 3. This is the x value. Whenever x is greater than 3, function is increasing. Now, when is function f of x decreasing? It's decreasing when x is between -2 to 3. So whenever x is greater than -2 and x is less than 3, function is decreasing. Y value, f of x is the same thing as y, is getting smaller from -2 to 3. And increasing means the y value is getting bigger. Now, when is f of x greater than 0? In other words, when is y value greater than 0? Y value is greater than 0 whenever f of x or y is above the x-axis. So for which values of x is y above the x-axis? Well, look at this. Y is above the x-axis from -4 to 2, isn't it? And also, whenever x is greater than 4, whenever x is greater than 4, the y value, or f of x, is positive, greater than 0. Now, finally, when is f of x less than 0? This means for what values of x the y values are negative. Well, that happens when graph of y, or f of x, is below the x-axis. So it happens when x is less than -4, and also it happens when x is greater than 2 and less than 4. And you have to understand this concept in order to do next example. Now we're going to sketch polynomial based on these 4 given characteristics. So f is increasing when x is less than 0 and x is greater than 4. F is decreasing when x is between 0 and 4. And so forth. They give us when f of x is positive and when f of x is negative. So the best way to summarize these characteristics is you draw a number line. and you have to draw 12 of them. The first one will give us a summary of when f is increasing and decreasing. Second one will give us the summary of when f of x is above and below the x-axis. So notice, let's put 0 and let's put 4. Make sure design in order. So f is increasing when x is less than 0. Whenever x is less than 0, f of x will be increasing. And also when x is greater than 4, so increasing. Now f is decreasing when x is between 0 and 4. Okay, so I hope you understand my summary of increasing and decreasing of f of x. Now let's talk about when f of x is above or below the x-axis. Well, it says f of x is greater than 0, which means above the x-axis when x is -2 and 3. Again, make sure design order, -2, 0, 3, and 4. So, and then we have 5. And f of x is positive between -2 and 3, so it's above the x-axis. And whenever x is greater than 5, it's also above. And f of x is less than 0, which means below the x-axis when x is less than -2. And from 3 to 5. Now, these two summaries will help us to sketch the polynomial that has these 4 characteristics. So let's sketch f of x based on these two summaries. Notice what happens from -infinity to -2. F of x will be increasing and stay below the x-axis. So it's going to be increasing and stay below until -2. What is our next interval that we need to look at? -2 to 0. What happens from -2 to 0? F of x will be increasing and stay above. So it continues to increase. It's going to be above from 0 to -2 to 0. What's our next interval? 0 to 3. We need to see what happens from 0 to 3. What's happening to f of x? Decreasing and stay above. Decreasing and stay above. So something like that. What is our next interval? 3 to 4. What's happening from 3 to 4? F of x is decreasing and stays below. Decreasing and stays below. Now, we don't know how far it's going to go down, so don't worry about that. Remember, our goal is to sketch how the polynomial looks like. Now, what is our next interval? We looked at 3 to 4. Now we have to look at 4 to 5. Increasing and stays below. Increasing and stays below from 4 to 5. Increasing and stays below. Now, what is our next interval? 5 to infinity. What happens? Increasing and it stays above the x-axis. So that's how our polynomial will look like. That's based on those 4 characteristics.